Okay guys, so continuing from where I left, this is probability distribution. I guess this should be 0.01. It won't go beyond that, so because I calculated just now. So 0.01, 0.05, both are the probabilities of getting 4 red balls, but the difference is this is calculated mathematically. In an ideal world, this is calculated in a sample of 100. Maybe if we take a sample of 1000 people or 5000 people, this probability might tend to be equal to this, but still this probability would still be not that accurate most of the time. Both of these are probabilities, but in this thing we are going to distribute an amount of money based on the probability. That's how the probability distribution comes into picture. Actually, not amount of money, it can be any weight. So for example, if we go in this scenario itself, continuing from here, the company who is conducting this survey is going to award 1000 rupees if you get all 4 red balls, and the entry fees to this survey is 500 rupees. So basically everyone gives that entry fee. The thing is, this guy doesn't get anything. Sorry, not this guy. 2 red and 2 blue. This guy doesn't get anything. The guy who gets 3 blues or 3 reds would get 250 each, and the guys who got all 4 R's would get 1000 rupees, and the guys who got all 4 blues would get, let's say, 800 rupees. You know why I'm keeping these two different, although these two looks to be same? Because the probability of getting a blue ball with respect to red ball would still be more, because there are 3 blue balls than 2 red balls. So I'm just keeping it like this, right? Now the probability distribution is nothing but the amount of money which the company conducting the survey, the company who's conducting the survey, they have to calculate how much amount of money they'll get or will lose doing this survey. So since everyone gave 500 rupees for the entry fee and there are 100 participants, so this is company, this is their debit, this is their credit. So before even starting the survey, they already have plus 50,000 rupees they already have in the starting, right? The entry fees. Now for the 5 guys who earned 5,000 rupees, they lost basically 1,000 rupees, so minus 5,000. For the 7 guys who got all 4 blues, 800 into 7, which is 756, 600, they lose 5,600 rupees. For the 20 guys who got 250, 500, and they lost 10,000 rupees. And again, for the 28 guys who got 4 red, 3 red and 1 blue, who still get 250 rupees, is basically minus 250 into 28. 250 into 25 is this should be 5,000 rupees, and this should be 6250 plus 750, 7,000 rupees. It is getting a bit untidy, so I'll just repeat. 50,000 they got in the starting as a fees from people participating in the survey. 5,000 they lost to the top 5 people who got all 4 red balls. 5,600 they lost to all top 7 people who withdraw all 4 blue balls. They lost 5,000 rupees to the people who drew 3 blue balls and 1 red ball, and 7,000 they lost to those 28 people who drew 3 red balls and 1 blue ball. Still, if you see 10,600 and 12,000, 22,000, in all they lost 22,600, but they still in the end of the day earned 27,400 rupees. That's how casinos work. They keep a top price very attractive because they know the probability would be very less. And then these two are average cases. This is a very average case. 2 red ball, 2 blue balls. Yes, very average. So that's why they don't have any amount on this one. And then these two, again, 3 reds and 3 blues, it has lesser odds of occurring, so that is why they have an amount of 250 rupees. But they just make sure by calculating probability distribution that at the end of the day they do not end up paying more than 50,000 what they took as a fees. Fees is nothing but the you can say when you enter into casino, there is a must buy of 1,000 rupees or 1,500 rupees of worth of coins. That's how they do. That's their fees basically. Okay, so how I calculated this is the amount of money. That's how this whole calculation is done. Now I'll relate this calculation